Once a web app can talk to an API server, the next step is to decode JSON responses from it. The JSON format is very popular for talking to API servers. It consists of 0, 1 or more key value pairs surrounded by curly braces and separated by commas. There are some challenges when decoding JSON responses in Elm web apps. The JSON format can include optional fields. Also, the JSON format allows some complex structures, such as values that have other JSON objects with more key value pairs. Still, if the JSON format is well known in advance, then Elm web apps can decode those responses with the help of the JSON Elm package. Here are some very basic examples of how to decode JSON strings. After installing the JSON package, we need to import JSON decode, import it as JD for convenience to avoid typing JSON decode every time. Let's say we want to decode a string with a value 12, which is valid JSON. We need to call the decode string function with two arguments. First, the expected data type, which is an integer with lowercase I since it's from the imported JSON decode module. And second, the JSON string to be decoded. Decode string returns a result type with either an error or an integer. Since the input string is valid, we get the OK integer. In contrast, if we call decode string with an invalid input, such as this string, the result is an error with details about what went wrong. Here is a very basic JSON response, which has the order ID key and an integer value. To decode it, first we need to define a new type alias, which maps closely to the structure of the JSON response. Second, we need to define a new decoder to handle JSONs like this. The new decoder calls the map function, which links the new type alias to the JSON format. The first argument of map is the order type alias, and the second one is a call to the field function, which expects an integer value for the order ID key. The new decoder is then used as an argument to the decode string function. The other argument is the actual JSON string. Since JSON keys are enclosed within double quotes, order ID must also be enclosed in double quotes, which are escaped with backslashes to avoid confusing the Elm compiler. Since the input JSON matches the decoder's expectations, the result is OK with a new order record that respects its type definition. Let's have a demo and decode a slightly larger JSON response. We are going to start by preparing a new order.json file to act as a response from our API server. Then we are going to install the JSON Elm package, add a new decoder, then add data from the JSON response to the status of the shopping cart so that users get details about their submitted order. On the demo machine, right-click the server data folder to add a new file called order.json. Inside the new file, add some curly braces, an order ID with the value 1234, and a delivery key with a string. Your order should arrive tomorrow morning. Save the file, then modify the URL in the submit order command, change it to order.json. Now we need to install the JSON Elm package to decode the API response. Go to the View menu and click Terminal. Enter Elm install elm/JSON. Confirm with yes. All good. It's okay to close the terminal panel. Go to the top of the page and import JSON decode as JD for convenience and save the file. We need a new type alias for the decoder. Let's call it order response with order number as integer and delivery estimate as string. Now we can add the new decoder. Let's call it order decoder, which is a decoder of an order response. The decoder calls the JD map function, which includes several such functions depending on the number of fields to be mapped. Since we have two fields, we need to call map2, which maps the two fields of an order response. The first field uses order ID in the JSON file and an integer type. The second JSON field is called delivery and it's a string value. We are ready to use the new decoder. Question for you: which variable has the response string from the API server? Indeed, response text should now return a string with the content of order.json. To decode it, add a let_in block with a new local variable named decoding result, equal to a call of decode string with a new decoder and response text. Add a new variable named new status with a case expression to check the decoding result. If OK response, then return the new status as your order ID is, then string from an integer, which is the response order number. Leave a bit of space and the delivery estimate. In case of an error, then set the new status to no order ID, we'll call you later. Now add the new status to the returned model. Save the file, looks good, no errors, switch to the browser and refresh the page. Place the order and we got the order ID and the new status. Perfect! In this module, we got our shopping cart to talk to an external API. We started by looking at the challenges of getting data from an API and solutions such as the maybe and result special types. We looked into how commands enable Elm web apps to interact with the outside world, for example, to send HTTP requests to an API. We sent our first request to an API server and got back a response. Finally, we used the JSON package to decode the JSON response from the API server. The next module is the final one. It's about talking to JavaScript code, since Elm web apps need to play nicely with existing JavaScript code.